N M M C triple E Unit 3 Multiple integrals revision. Multiple integrals revision. Multiple integrals, first right here, lesson 1. Multiple integrals, two types. Number 1, double integrals. Double integrals. Number 2, triple integrals. Double integrals. Number 2, triple integrals. Heading 1, double integrals. Integral x1 to x2, integral y1 to y2, f of xy dy dx denotes the double integral. Denotes the double integral. Here f of xy is a function of x and y, and y limits are y1 to y2. X limits are x1 to x2. x1 to x2. Y limits evaluation. Now evolution method. Type 1. Type 1A. Double integral x1 to x2, integral y1 to y2, f of xy dx dy. When x1, x2, y1, y2 are constants, integrate f of xy first with respect to x, and then with respect to y, and then with respect to y. Type 1B. Double in x1 to x2 integral y1 to y2, f of xy dy dx. When x1 comma x2, y1 comma y2 are constants, integrate f of xy first with respect to y, and then integrate with respect to x. So what is your observation? Limits are, in both integrals, all limits are constants. According to order of integration, you integrate first with respect to y, next with respect to x. Here also all limits are constants. Here order is first to x, second one y. First x, second one y. According to this order, you integrate it. Whenever all limits are constants, according to this order, here a dx dy there, first with respect to x, second with respect to y. Here dy dx is there, first with respect to y, second with respect to x. Type 2, integral x1 to x2, y1 is a function of x, y2 is a function of x, f of xy dy dx. So here y1, y2 are functions of x. So when y1, y2 are functions of x and x1, x2 are constants, integrate f of xy first with respect to y, keeping x as constant between the limits y1 comma y2, and then resulting function is integrated with respect to x between the limits x1 comma x2. So your I is integral x1 to x2. y1 is a function of x, y2 is a function of x, f of xy dy dx. Type 3, x1 to x2. Type 3, integral y1 to y2. x1 is a function of y, x2 is a function of y, f of xy dx dy. When x1 comma x2 are functions of y and y1, y2 are constants, integrate f of xy first with respect to x, keeping y as constant between the limits x1 and x2, and then resulting function is integrated with respect to y between the limits y1 comma y2. Here I is equal to integral y1 to y2 x1 y2 x2 y f of xy dx dy. Examples. Observe these examples. Suppose I is equal to integral 2 to 4 integral 0 to 3 x square plus y square dx dy. That is given this one. Here limits, all limits are constants. 2 to 4, 0 to 3. What is your order of integration here? Dx. First you integrate with respect to x. These are x limits. These are y limits. That is the meaning. First you integrate with respect to x and then integrate with respect to y. Suppose I is equal to 0 to 1, 0 to 2, x square y cube dy dx is there. Here also all upper and lower limits are constants. According to order, we first integrate with respect to y and then integrate with respect to x. So these are y limits, these are x limits. That is the meaning. First, second. Another example. Suppose I is given 0 to 1, y square to 2y, x plus y dx dy. What is its meaning? X limits are y square to 2y. Y limits are 0 to 1. Here y is there, opposite variable x. So first integrate with respect to x. First integrate with respect to x. Then integrate with respect to y. According to given problem, observe carefully. Last example. Suppose problem is given 2 to 3, integral 2 to 3. Here 2x plus 3 to x square, some function xy dy dx. Here x is there, opposite variable dy. So first integrate with respect to y, second integrate with respect to x. These are y limits, these are x limits. This is the meaning. You observe 4 examples carefully. This is belongs to type 1a, this is belongs to type 1b, this is belongs to type 3, this is belongs to type 2. Observe carefully.